So let's recap what we've done over the last week or two. So we're looking at multivariate data, and remember multivariate data is where we have more than two variables. So we'll be comparing two groups with one set of measurement data. So for example, males and females and their heights, or two different breeds of animal and their heights or their weights. So let's just take this set of data here, and a reminder that we have 9 summary statistics. So these are the 9 that you see here: the mean, the median, the mode, upper quartile, lower quartile. IQR is shortened for the interquartile range, the range, and the maximum and the minimum. So a reminder of what these all are. So our minimum is the lowest number. So if we have a look here, 2 is our lowest number, maximum, fairly straightforward, 18. All right. Then our range is the max minus the minimum. So if we take 18 minus 2, we get 16. So our maximum 18, minimum 2. Then our interquartile range, in order to find that out, we first have to find the median and then the upper quartile and the lower quartile before we can find the interquartile range. So firstly, our median is the middle number. So if we divide it in half, we have 24 pieces of data. So if we find the middle is in between these two 8s here. So in this case, because it's between 8, the median is just 8. Okay, so remember, median is the middle number. If it's in between two numbers, you add them together, divide them by 2. So again, in this case, 8 plus 8, 16 divided by 2, 8. Then to find the upper quartile, we're looking at the top set of data, and we're finding again the median of the top set of data. And again, it's going to be in between two numbers. So our upper quartile is in between 10 and 12, because as you can see, there's 6 pieces of data here and 6 pieces of data here. So in between 10 and 12 is 11, so our upper quartile is 11. Again, if I was to add 10 and 12 together and divide it by 2, I get 11. Then find our lower quartile. So we look at the bottom set of data and we find the median of that, which is the lower quartile. Again, it's in between two numbers, between 5 and 6. So half of what is in between 5 and 6 is 5.5. So therefore, our lower quartile is 5.5. Then to find my interquartile range, it's my UQ minus my LQ. So upper quartile minus lower quartile. And 11 take away 5.5 equals 5.5. So my interquartile range is 5.5. Then remember, your mode is the most common number. So what number occurs the most in this case? We have 3 5s, 4 8s, 3 9s, so obviously the 4 8s will be my mode. And if there is more than one, it's called unimodal, so there is more than one mode. In regards to our mean, remember you add them all together and then you divide them by how many there are. So if we add all of those sets of data, all those pieces of data, and divide it by 24, which is the number that there is, and that will give you your mean, also known as your average. So then we can use those 9 pieces of data, or particularly 5 of them, to create a box and whisker graph. And the multivariate box and whisker graph allows us to compare two sets of data. So if we take this female box plot up here, so this is our box and whisker graph for the females. Our maximum is the highest number, so that would be at about 70. Then our minimum is at 1. Our median is this middle line here, and just a reminder that these 4 sections, so this from here to here is 25% or a quarter. From the median to the upper quartile is a quarter of the data. Again, from the middle here to the lower quartile is a quarter of the data. And between the lower quartile and the minimum is another quarter of the data, or 25%. So then our lower quartile would be about 10. Our median looks like it's sitting about 35. And our upper quartile about 54 or 55. So that is our 5 pieces of data on the female box plot. Same goes for the male. So we have our maximum, about 84, 85, our upper quartile, 65, our medium, 60, our lower quartile, 30, and our minimum, about 25, 26. We can then use this information to help us compare them. So the rule is you can make a call as to whether the males exercise for a longer time than females if their median, this one here, falls outside of the female's box and whisker plot, okay, particularly the box, sorry. So if I draw a line and it doesn't fall in the box, then I can claim that males tend to be exercising longer than females, even though the females one still falls inside the male's box. However, if these were spread apart and there was no median falling inside either box, you can definitely claim that the males exercise longer. So for example, if the female's median was here, we could claim that males definitely exercise for a longer period of time. However, if the male's median was here and the female's is where it stands now, then it would be too close to call. Because the median is generally a good representation of the middle of the data, we can't make a call as it's too close. So we can't claim that males exercise longer than females.